Okay, so we're in problems 2, number 8. Thought about it. Okay.
Problems 2, number 8.
David is standing on top of the school's roof that is 5.3 ms off the ground. He throws his graphing calculator at 9.75 meters per second at a 55-degree angle. And we want to know how far away it lands. Well, obviously this calculator is traveling what 2 directions?
Up and sideways.
Yeah, so it's going sideways. We can figure out what the VH is, and it's going up, so we can find out what the VBI is. How would we do that?
Cosine and sine.
Cosine and sine. Which one will we use for VBI?
Sine.
Very good. So we're going to take the sine of 55 times the 9.75, and then over here we're going to take the cosine of 55 times 9.75. And here we get 7.99. And here we get 5.59. Right?
Yes.
So we've got that made. So step 1, we had to break up our triangle. But of course, once he lets go of that calculator, the calculator is a projectile, so it's going to travel in a parabolic trajectory, so it's going to go through the air and come down, and it's going to break into a million pieces, and he's going to have a nice maniacal laugh, and he's going to say, ha 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 ha, I don't have to do physics anymore. And we're going to say, ha ha, you still have a test tomorrow. So it's going to travel like that, and what I'm asking for is how far over did it go, so we're really looking for DH, which of course is VHT. Now, can I use the range equation here? Why not? The range equation only works when time up is equal to time down. Which one's going to be bigger here? Clearly time down is going to be much bigger than the time up. But we already know half of this VH. We know the VH we figured out right here was 5.59. So now all I got to do is find out the time. Well, which direction is it going first?
It's going up.
So first or second, I'm going to find the time up. So I'm thinking I should probably use the time up formula. And the time up formula, of course, was VF minus VVI over G. And VF was always 0 when I'm going up to my highest point. So it's going to go up till it stops. My VVI, again, out of these numbers, the only one I want to pick is the one that's going straight up because I'm going into a time up formula. So make sure I only put in up values. So that's going to be 0 minus 7.99 over negative 9.81. And that, of course, gives me 0.814 seconds. So it'll take 0.814 seconds to get to the highest point. After we find time up, we'd love to find time down. But the problem is, to find time down, we have to find out how much time it takes to fall down. But when do I start falling down? Way up here. And the only height I know that I'm falling is the 5.3 over here. But I'm not falling 5.3, I'm falling something more than 5.3. So I have to figure out, well, how much more am I falling? So the third step really I have to find is how high do I get over that point? So I want to find a D up. Now there are 2 D equations that we can use. We can use the dV equals gt squared over 2 plus vvit, and we could use this time that we just figured out, the 0.814, because that's going to be the time it takes to get to the highest point. We can do it that way, but I think the other D equation is easier. So the other D equation is the VF squared equation that solves for D. And if we do the VF squared equation, it's going to look like this. And the reason I like this one is because this one looked just like the T up equation. There's just 3 2's added. So I already got the numbers figured out for that. All I got to do is stick in some 2's. So I'm going to have the 0 squared minus 7.99 squared. So notice how it looks the same numbers as we had right there. We just added 3 2's to this situation. So if we do this, we find out it went 3.25. So it went 3.25 meters up, which means how far is it going to fall down?
8.55.
Very good. So what you just did was step 4. You said, hey, I'm going to add the 2 distances together. Because I know it's going to fall 3.25 meters from here to here, and then it's going to fall another 5.3 all the way back down to the bottom. So I'm going to have the 5.3 and the 3.25, and I say, hey, that's going to add up to... So then we say, hey, now we can find... That was pretty. Now we can find the time down, which of course is the square root of 2dv over g. So then I say, well, the whole reason I did step 4 was to find this, so I can stick this in there. So we're going to have the square root of 2 times the 8.55, which of course, since it's falling down and that's a displacement, needs to be negative. So we could subtract by negative 9.81 and not freak out our calculator when we take a radical. Or you could just say everything under the radical is always going to end up positive. I got 1.32. Also. So is that the number I was missing here?
Yes.
No.
Are you asked both?
Because yes, this is my time down, but this was my time up. So step 6 says I need to. Yeah. So I'm going to have my time up plus my time down. Those are some weird T's, man. Okay, so my time up plus my time down, so I'm going to have 0.814 added to 1.32, and I'm going to have total. So that's what I was missing right there. That was a short class. I'm joking.
Oh, that's funny.
So then we multiply these 2 together and we get. And then you go back and look, and my smallest number I had to begin with, I had this one had 3 6 figs and this one only had 2, so I'm going to round this off to just 12. Isn't that lovely?
Not like people.
It was supposed to sound like Marvin the Martian.
Oh,
Not really.
Did you look?
Red sounded like PB.